Let me add my sincere thank you for joining us, what is 3 years almost to the day from when we were last here in this same awesome facility. We've been busy over the last 3 years, and I think you all have been too, and we've got a bunch of really cool things that we're going to share both in today's keynotes, tomorrow's keynote, as well as the sessions both this afternoon and tomorrow that just underscore a little bit of what we've been doing over that time period. I also hope to use this conference as an opportunity, whether you're online or whether you're here in person, to connect with each other, because obviously that's one of the real reasons why we do what we do, by bringing folks together here for our annual conference in Europe, and we also do one in the United States. So for me, a heartfelt thank you for participating in our community. Genuinely, I just got to spend some time with folks last night that just remind me the depth of commitment to our community, to our products, that is truly, truly awe-inspiring. And so a sincere thank you from me. You are literally why we do what we do. So since the last time we've been here, a lot of things have changed. For one, we just crossed over 2,000 employees earlier this year, which was probably about 4 times what we were when we were here last time. We also went through the public markets. The reason we did that is because we understand what it means to play the critical infrastructure role that we do for some of the biggest companies in Europe, and we want to be able to send that signal to all of you that we are deeply, deeply committed to that role financially. I also want to share some of the numbers that, that sort of come to mind over the last 3 years. Not only do we have 3,000 people attending us online, this room here is at capacity as well, and that community has driven over 250 million downloads of our products over the 12 months ended in January of last year, which is a truly, truly staggering number. We also have over 20,000 experts around the world that have become certified on our products. What I hear over and over and over again is that the biggest gap to cloud computing is, in fact, the skills gap. We've invested deeply in the certification process to help certify people around our products, to send the signal to the market of a level of standardization and competency around things like Terraform, Vault, Consul, et cetera. We've also reached over 41,000 members in our user groups, which is no small feat given that this has all been digital over the last few years, and that spans 55 countries and 153 chapters around the globe. When it comes to our partner ecosystem, we haven't been standing still either. We've added over 2,000 Terraform providers to our ecosystem. So if you go to registry.terraform.io, you will see that there are over 2,000 Terraform providers. There are over 900 integrations across our overall portfolio because we believe driving standardization is good for everybody. Those integrations and providers span not just our cloud partners, but also the technology partners that you use each and every day. So if you want to use Terraform, for example, to provision and configure Cisco ACI or Palo Alto Networks or your vSphere estate, the work that we've done in the community has enabled that to be possible for all of us. And then lastly, we have a whole roster of system integrators that allow us to enable our customers to get to cloud in the tried and proven way that we all know best here in the room. You can see many of those not just span the biggest global system integrators on the planet, but many of them are regional system integrators, some of whom are represented here in the room today, that really are the key to unlocking that skills gap that makes this all go. And now we're actually over 3,000 customers. We were reflecting, I think last time we were here, we probably only had 600 or 700 customers. We actually added 500 net new customers last quarter, which gives a sense for the kind of the continued unabated growth in overall customer base. That includes some of the most notable companies here in Europe, like Decathlon, Swisscom, Airbus, Lufthansa, Sky, and many others. And as we started to offer our products as cloud-managed services, that friction of onboarding to become a customer is actually being greatly reduced, and we're seeing this scale and velocity of customer adoption accelerating. All of these numbers were big 3 years ago, bigger last year, and even bigger now. And the reason is because this shift to cloud just continues unabated. We are publishing the HashiCorp's State of Cloud Strategy Survey in a couple of weeks, but I'll give you a sneak peek. This says a full 81% of respondents were implementing, expanding, or planning to expand their multi-cloud estate in the next 12 months. So not only is cloud a thing, but multi-cloud is a thing, which just underscores the need for the commonality of approaches around things like provisioning and security and networking, because just practically speaking, it's way too hard to learn how to do this on every single cloud provider differently. So the most common question we actually get as we sort of transit the world, now that we're all traveling again, is what's the smart way to adopt cloud? What are the patterns that you see as you sort of engage with all the biggest companies around the world around their infrastructure plans? What are people actually doing? Well, it's actually very, very consistent. We kind of call this sort of this way that everybody starts their cloud journey, the cloud V1, which is, hey, we got to build a mobile banking application or whatever the app might be. I sign an enterprise agreement with Amazon. We all get after it, and 6 months later, someone goes, whoa, 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 whoa. You're way over your Amazon entitlement, and you've got a bunch of apps that the security team is freaked out about. Stop. That V.1 or V1 of the cloud program, sort of the cloud journey, is actually very, very, very consistent. Because some kind of governance has to be applied to this, some kind of policy has to be applied to the cloud adoption process. So even though you're using things like Terraform and Vault and Consul in open source form when you're adopting that cloud V1 moment, the actual constraint organizationally is that the ops security and networking teams, by and large, slow you down. So in every company that we see successfully adopting cloud, they have this notion of a platform team. Now, they call it something different. You may call it your SRE team, your DevOps team. It may just be 3 or 4 people inside your business group that are building applications to say, hey, I will play the role of platform team. And to me, it is actually analogous to what happened in the VMware virtualization world. For virtualization to really take off, you needed the VI admin role to be created as the central point for provisioning of virtual machines to everybody that required it. Once that was in place organizationally, you saw the real acceleration of virtualization. And I think the analog in the cloud world is the platform team. That small group of people that stands up a set of common shared services that say, hey, I may have 10 different business groups on the left. They're trying to deploy apps to 3 different clouds on the right. I need to create this common substrate so I can apply policy. So I can't have 200 Amazon accounts. I need 1 Amazon account, and I want some way to broker and apply policy to it. So in the new world, that cloud platform team is the analog in our view, and every company that is adopting cloud successfully goes down this path in some way. This is sort of what we call to its cloud V2. Then the rise of the platform team is sort of the key to the whole thing. What this allows is actually the application of, cost reduction, risk mitigation to the whole process of delivering apps to cloud by saying, hey, you can't just willy-nilly deploy anything to cloud. You can only use this pre-approved Terraform template. You can only authenticate your identity of every application using Vault, for instance. And so by solving that core platform team problem, you have the ability to provide self-service to your developers who want to be able to deploy things while applying a modicum of governance through cost reduction, risk reduction for the enterprise, and ultimately allows you to deliver apps faster to those multiple cloud endpoints. What you've seen HashiCorp do is play that enabling role for those platform teams with their commercial offerings. So that's literally how this whole thing got started, which is people using our open source products for that V1 motion, but really our commercial products are our cloud offerings for the V2 motion. Curiously, as we developed the cloud managed offerings of ourselves, we had to go through this exact same transition. So if you think about what we had to do, we had to say, hold on a second, we have 4 different business groups. We have an application team that builds Waypoint, Nomad. We have a security team that builds Vault and Boundary. We have a networking team that builds Consul. We have an infrastructure team that builds Terraform, Packer, and Vagrant. The challenge became for us, we wanted to offer the HashiCorp Cloud Platform, i.e. managed applications running on more than 1 cloud provider. Sound familiar to all of you? We had exactly the same problem that you all did, which is how do we actually do this? How do we have, almost, many, many 100-person engineering organization split across different aspects, different business groups, deploy applications in a consistent way to multiple targets? The answer for us, obviously, was a platform team. So we, in fact, have 4 product teams and a platform team, just like our customers do. And this is what unlocked the application velocity for us. This platform team allows us to apply zero-trust security in a consistent way, whether those apps are going into containers running on Amazon or into VMs running on bare metal or on core infrastructure or on private data center. It doesn't matter because the policies and governance is made by that platform team. So we, in fact, much like the shoemaker's children, have adopted our own products to run our own services and gone through that exact same journey. You'll hear a lot of folks talking about this at the conference today. In fact, you all know this either explicitly or implicitly because many of you are the platform teams inside of your organizations. So we've been working on a lot of really cool things across that stack because our view is that that platform team needs to run a consistent set of infrastructure, Terraform, Vault, Consul, almost universally. Most of the big companies we work with do that. And so we've been working on innovations across all 4 aspects of the stack, which we're going to share a fair amount about at today's conference. So without further ado, I'm going to pass things over to Armon to walk you through what you're really interested in, which is the product evolution that we're going to introduce based on some announcements today. Armon? All right.
Thank you so much. Hey, good morning, everybody. Thank you so much for joining us. It's awesome to be back here, and thank you so much, Dave, for kicking off day 1 for us. So as Dave mentioned, I'm super excited to be back up here. We're going to share a ton of product updates. As you know, we have a very wide portfolio, so we decided we're going to split them between day 1 and day 2. And so for today, for day 1, we're really going to focus in on the infrastructure layer as well as the application layer. And then tomorrow morning, we'll go into the security and networking layers. Lots to talk about across all of it. So let's just kind of jump right in. As Dave was sort of teeing up, I think we often think about the different personas and different teams within an organization. And oftentimes, it's that platform team Dave talked about that's building the underlying tools, supporting the application teams, who are there sitting on top of that, delivering their applications. And there's obviously sort of a related set of challenges, but the journey is a little bit different. The skill sets are a little bit different between them. And so we really think about what do we need to do to support both of these sets of users on their journey to cloud, right? And so we think about it as often it starts at that base layer with provisioning and the underlying infrastructure, which is how do we actually build the underlying infrastructure that the applications ultimately are going to run on top of. So the way we think about the start point of this is it starts with infrastructure as code, right? As we're going out to cloud, it's really about establishing that core workflow, building it into our CI/CD process, and enabling our developers to then build new infrastructure, provision it, as they're going, and doing it in sort of a more automated, sort of end-to-end way, right? It kind of starts there. That second phase, though, is once we go beyond the first 5, 10 application teams, and we start thinking about how do we support 20 application teams, 50 application teams, and beyond, it starts to be around how do we actually standardize our approach to cloud, right? And this might be thinking about things like Terraform modules, for example, right? I want to have a reusable blueprint so that every team isn't reinventing how we do a database or a network or core application service. So we start thinking about great reusable templates, using Terraform modules, starting to put things like policy as code in place to create the right guardrails to make sure that as we're going to cloud, we're doing it in a sane way, using the right instance types in the right regions, et cetera. And then you ultimately get to sort of phase 3, which is great. Now we've enabled all these application teams. How do we sort of operate at scale, right? And this is really about continuous operation of our infrastructure and sort of optimization on an ongoing basis, right-sizing our resources, making best use of our cloud spend, et cetera. So ultimately, when we think about sort of the full vision of Terraform and what we've been focused on, it's really that full gamut, right? It starts with what's the core workflow? How do we enable something that is going to be easy to use, elegant, fits into what we want to do from sort of a CI/CD perspective? But 2 is ultimately super extensible. So this goes back to the point Dave was making around that broad ecosystem of whether it's technology partners or ecosystem partners that we work with, which is ultimately your infrastructure has to work with all of the different tools and technologies. And so this is where Terraform is a huge and broad provider community. And then ultimately, lastly, it's about how do I manage all this infrastructure, right? Because it's an ever-growing estate, whether it's our cloud estate or our private data center. There's sort of an ongoing management. It's not just, great, I stood up the infrastructure, day 2 and beyond, I still need to manage that. So we introduced Terraform to kind of think about all these problems and start chipping away at it and introduce the concept of infrastructure as code back in 2014, and we've made an incredible amount of progress since. Today, we count over 100 million downloads of Terraform on an annual basis. That includes over 200,000 Terraform Cloud users. And when we talk about that ecosystem around Terraform, that's where we talk about over 2,000 different providers now. That includes 200 plus different technology partners, hundreds of integrations, and thousands of customers. So the Terraform ecosystem is large and growing, and continues to grow rapidly. So today I wanted to spend a little bit of time talking about some of the what's new, right? When we think about where is this all going, what are some of the challenges that we see around that sort of standardization phase? Once we've moved beyond just the basics of kind of the infrastructure as code workflow, how do we really think about infrastructure at scale? And so I think one of the challenges we've seen is people start with Terraform, they sort of define the infrastructure day one, but there's often this question of like, great, yeah, I can provision it, but how do I know it's actually functional, right? Like Terraform Apply said it was successful, but do I actually know that the infrastructure is working? How do I run water through the pipes in some sense to make sure that it works the way I think it should? And so this often brings us to the concept of how do I test Terraform code? And this has been a big, big ask from the community for quite some time, is how do I actually functionally validate that my infrastructure is correct? And so I'm excited to talk about some of the features that we've been introducing very recently with Terraform 1.2, which is the concept of pre- and post conditions. So these allow us to bring in line to our Terraform definition sort of functional testing and validation of how our infrastructure should work, right? How we expect it to work. Preconditions obviously being as Terraform's executing, this is something we expect to be true before we even create the resource. So before I want to instantiate, a particular resource, might be an expensive resource, what needs to be true about my inputs, or what needs to be true about the state of infrastructure? And then a post condition is after I've created it, what should be true afterward, right? If I create my load balancer, for example, if I hit that thing, I should get a 200 OK back. That means I'm running a certain amount of water through the pipe. I have to hit the load balancer, it has to go to a backend service. That thing needs to be able to communicate to its database. Otherwise, I'm not going to get my 200 OK, right? So when we talk about these sort of preconditions, now these are sort of inlined within the actual code. So I want to sort of look at an example here, right? So in this sort of a simple scenario, what we want to do is install a lifecycle condition. So within that, you now define a post condition. In this case, it's on an AWS instance type. And what we're going to assert is that the volume size is at least 10 gigs, right? So this is a very basic example. You can imagine we have a Terraform module that helps a user provision, for example, a database, and an input to that module might be an instance type. Well, if a user provides the wrong type of instance, they might not think about it. Terraform will happily go and provision that database. It'll come up, Terraform Apply succeeds, but you're at risk because maybe you brought up a device that only had a 1 gig disk, and great, the database works for a day and then it falls over. So this starts to allow us to put in that kind of post condition. Great, we provisioned it, now we're validating, does it work the way we expect? And if not, we're going to return a helpful error message to the user. Rather than some vague thing, they're going to get a very useful message back saying, hey, your database server is incorrectly configured, right? And so an example of what that would actually look like, right? So here we'll actually go through. User is going to do a run, right? Kind of go through kind of classic Terraform workflow, actually do a provision. And we'll see that once we kind of get to the end of the apply, the provisioning took place, but Terraform is now validating that post condition and returning that error message back. So now we're going to get actually something helpful back, as opposed to saying, great, it's going to fail at some point in the future, and you don't really know why it didn't work, right? So this is now available as Terraform 1.2. As you can see, it's sort of natively already working as part of Terraform Cloud, Terraform Enterprise. So you can start leveraging these pre- and post conditions in your Terraform code today to start baking in that sort of functional check, right? And whether that's in sort of an end application and you're functionally validating it, or it's in a module and you're making sure that the inputs and outputs and the function of the module works correctly, you can kind of use it at multiple different layers. So if we move beyond that kind of day one, right, that pre and post condition is letting us say, great, not only at Terraform apply time do I know that it got created, but I know that it's functionally valid. It works the way I expect. But what about day 2, day 3, day 5, day n, right? As we know in the real world, things are dynamic. Someone's going to log into our AWS console and reconfigure a resource or SSH in and muck about with something. And so in the real world, things tend to go adrift, right? Because whether it's just sort of the chaos of operating in cloud environment or the fact that we have sort of manual intervention with things, things tend to move away. And so this has been a problem that we've known about, and I think people have had different kind of solutions to, but we really wanted to take a first-class attempt at solving this. So I'm super, super excited to introduce and talk today about sort of the introduction of drift detection as kind of a first-class capability within Terraform. So what does this actually look like? Right? I want to kind of take a look at it sort of in practice. So now when we're within sort of our Terraform Cloud context, you can see that there might be a little tag that shows up. In this case, you see that sort of drift, sort of yellow box. And so in the background, continuously, we're going to be running effectively a refresh and drift detection process. So without you having to actually run a plan manually, Terraform will just be executing against the last known good run and basically detect if things change. So in this case, we can see for this workspace that we've detected for some reason these 3 instances have gone missing. Right? Maybe somebody logged into the console and manually deleted them, or the actual instances failed. Who knows? But now this gives us a few different options, right? A, we can get notified about it, so we can configure and say, hey, send me an email, send me a Slack. I want to know when there's drift in my configuration. But B, we can actually come back in and either rerun Terraform against the last known good configuration and have Terraform snap it back. Or we might say, that we expected that to be the case, right? We might have manually done this change, and we want to accept this drift, basically, right? So this now gives us a few different options, but really starts to move Terraform from just day one, I provisioned the infrastructure, into great, how am I continuously thinking about it, right? And so that runs not only just checking for drift and the resources we asked for, but those same preconditions, post-conditions that we talked about, right? So this now allows us to kind of do that type of monitoring on a continuous basis and say, you know what, my load balancer should always return a 200 OK. If day 90 it stops returning it, I want to know, right? Something is wrong with my infrastructure. So this is now available in public beta. It's getting rolled out to all of the users on Terraform Cloud. So if you log into your account, you should start to see it get lit up and enabled. And we're going to roll it out to all the users there shortly. And it'll be coming soon to Terraform Enterprise as well. So super excited about this, really moving Terraform out of just day 1 into day 2 and beyond. So now as we go back and we're sort of talking about standardization, that a different set of challenge that we've talked about is really that notion of the policy framework. How do I make sure that as users are iterating, they don't accidentally open up my firewall, create an S3 bucket that's public, use the wrong instance type. So that's really where we built Sentinel as our policy as code engine to kind of put those guardrails in place. And that was introduced in about 2018. Since then, we've enforced 12 million Sentinel policy checks as part of Terraform Cloud, and we've blocked a few 100,000 runs that would have potentially introduced production issues. And so we've seen a huge uptake in this notion of policy as code in terms of how do we automate those guardrails without having to resort to a manual ticketing process or human code review. But one feedback item we've consistently got is how do we make it easier to write these policies, share them, publish them, reuse them within an organization. And so the way we've historically done this within the Terraform community is through the Terraform registry. That's where we share modules. That's where we share providers. And so what I'm excited to announce today is that policies will also be moving into the registry as well. So this is a look at what it's going to look like. This will be coming soon. You can see in addition to providers and modules, now you can search policies. You can find things like, for example, a foundational policy set. And then from that, you can go in and basically import those policies into your accounts, right? So in this case, it might be sort of a CIS set of benchmark standards. And so you don't necessarily want to have to rewrite those every time, right? It's a common set of standards. It's a common framework. You want to be able to just search the registry, find it, import it, and start enforcing all of those policies against your existing workspaces. So this is really part of looking at how do we make this easier to consume and use these things right out of the box without having to go and rewrite common policies for common situations. So this will be coming very soon. So beyond just our Sentinel framework, what we've also seen is a desire to plug in other tools within the broader ecosystem into the Terraform workflow. So earlier this year, we made generally available Terraform run tasks. So this extended the workflow so that you could bring in other tools through sort of a webhook ecosystem and plug it into the existing Terraform workflow. So this lets you fit it into many different types of challenges, right? You might solve a set of security challenges by integrating Sneak to do static code analysis. You might use tools like Turbonomics for doing cost control or cost management. You might use different tools for doing regulatory and security compliance. So there's a big ecosystem of tools. At the time of launch, we had 12 different partners with us. I think that's now north of 20 different integrations that are native with Terraform Cloud. So as you're using these other vendors, you can now use the webhook ecosystem to integrate them as part of that Terraform workflow. Now, one of those integrations is our very own. It's HCP Packer. And this is a new service that we launched earlier this year, really looking at how do we make that immutable image building workflow work end-to-end from sort of Packer with the image build all the way through to Terraform with the actual provisioning of the infrastructure. So for those that are maybe unfamiliar with Packer, it's a tool for building golden images, right? And so that might be a machine image, right? It might be a VM image for a private data center. It might be an Amazon, Azure, Google image for cloud. It might be a container image for Kubernetes. It doesn't really matter to Packer. Much like Terraform, the idea is I want an infrastructure as code template that says, what are my inputs? My source code, my config management, my security controls. Those are the input to Terraform, and then it integrates with all these different environments to enable us to build an artifact, whether it's a container or an AMI or whatever it might be, in an agnostic way. So much like Terraform, it sits a little bit to the left in terms of building the underlying image. So this is a very, very popular tool in terms of how people build their golden images and adopt an immutable approach to infrastructure. But the challenge that always existed with Packer is how do I actually manage all these images, right? I might say every week I do a rebuild of, let's say, my secure baseline operating system. And so I have a versioned OS that has my hardened patches. But how do I actually provide that to all my application teams? How do I make sure my Terraform code is using the latest up-to-date version? And so what we often saw was sort of copy-pasting that as a variable or having to sort of create some duct tape and glue. And so this is where HCP Packer comes in. So the workflow that HCP Packer then enables is once you're running Packer, within your Packer definition, we basically define a snippet that says, hey, at the end of that run, upload this image to the HCP Packer registry. So then it manages all the metadata for that. So in this case, we have our CentOS web server for AWS. And so every time we can run now Packer in an automated way, it's going to publish and say, great, this was version 1, version 2, version 3 of that image. And now we can query that in a dynamic way. So the flip side of that then is the Terraform side. So we might want to provision that same CentOS image from Terraform. I don't want to hard code the AMI ID. Or I don't want to use a variable that I have to copy paste. Instead, you can see we're going to use a data source to directly query that registry. So now I can have one CI/CD pipeline that runs Packer every week with those new images, and it uploads it. And then every time my developers run Terraform to deploy, they can pick up the latest version without having to sort of deal with munging that back and forth, right? And so this allows us to now have an elegant end-to-end workflow. Now, this connects back to Terraform because we can actually now use the run task integration to allow us to solve richer workflow challenges like security remediations. So as an example, let's say we have an operating system image that has a known vulnerability, right? We're running an old Linux kernel version. It turns out that thing has a CVE for it, and we revoke it. The integration between HCP Packer and Terraform allows us to say, hey, I want to revoke a version of that image. And you could see that you got an error message when the user tried to deploy that. So we tried deploying an old version of the AMI. Now we can go into HCP Packer and promote a newer version, right? So maybe we're trying to deploy version 1. Now we're going to try and deploy the latest version. And when we rerun it, now we're running that run hook between the two systems, validating that, great, we're not trying to deploy an AMI that has any known vulnerabilities or that's been revoked in the meantime. And so, great, that run hook passes. We're allowed to actually apply our change. So HCP Packer plus Terraform allows us to now have that end-to-end workflow around how do we do immutable image builds and then thread it all the way through. And then using run hooks, we can start to think about those sort of security remediation workflows on top of it, right? I think we've all seen the case of, someone deployed a known bad AMI because it was, hard-coded as part of Terraform. And, great, that thing has, some well-known OpenSSL vulnerability as an example. So really looking at how do we start to improve that end-to-end. So taking a quick step back from just Terraform, I think there's been a lot of different focus areas for us, right? With Terraform 1.2, really starting to think about pre- and post-conditions and how do we bring more native functional testing into Terraform itself. You'll continue to see us push on that. Second is with drift detection, really thinking about how do you move beyond just that day 1 validation into day 2, day 3, and beyond, right? And so continuously validating those pre- and post-conditions, looking for drift, checking for any misconfiguration, being able to alert on that. Extending policies into the registry to make that easier to use and share and be able to start quickly rather than having to start from scratch. And then extending that universe of our workflow with these run hooks into different systems, both HashiCorp and external, right? And then HCP Packer, kind of a core companion to enabling that end-to-end immutable approach to infrastructure as code. So there's going to be a lot more about all of these in the breakout sessions. I encourage you to check out the schedule and then go into those. We're going to go a lot deeper into all these topics. So now I want to shift gears a little bit and move back up the stack a little bit, right? So we started with the infrastructure layer. I want to go back up to the application layer and spend a little bit of time there as well. So we're going to talk about Nomad and Waypoint, maybe starting here with Nomad. So when we talk about Nomad, most people know it as sort of the HashiCorp application orchestrator. And our goal for it has always been sort of twofold. One is how do we make it the simplest, application orchestrator? And two is how do we make it the most flexible? So these have always really been a focus area for us, right? Getting started with Nomad is as easy as a single command to launch your one-node Nomad cluster, and deploying and running jobs on it, is as easy as a single job file, right? So it's always been a focus on that developer simplicity. One of the areas we've been looking at, though, is how do we make it even simpler, right? I think the feedback we've often heard is, great, you still have to kind of understand the scheduler, its nuances, how do I write a job file to get going? And so very similar to a concept of like Helm charts in Kubernetes, we've introduced what we call Nomad packs. So this is a higher level sort of packaging format for Nomad job files. It allows you to sort of templatize and make them much more reusable. So whether it's for a common sort of application, maybe you're deploying Jenkins, for example, you don't have to write the underlying Nomad job for it. You can just consume a Nomad pack. Or within your organization, you might say, I'm going to write a common Nomad pack for how we do a Java app or a C# app, and sort of abstract some of the details of the scheduler. So really looking at how do we make it a little bit easier to package up, reuse, and share those templates for Nomad. Then when we talk about sort of the operations simplicity, continuing to look at different types of use cases, different types of patterns, and how do we make Nomad easier in those environments. So one of the things that we've seen more and more of is the notion of edge deployments, right? Meaning you might run a central set of Nomad servers and then have points of presence or compute all around the world, right? This might be a retail store that you're running something in, or a manufacturing plant, or distribution center, et cetera. You might not gonna run a full Nomads, cluster, but you need to run a few nodes so that you can push some applications and compute into that sort of point of presence or that kind of edge computing environment, right? Now, the challenge with a lot of those environments is you might expect them to lose internet and still function, right? If I'm at a retail store, I still need to be able to go in and buy whatever I'm buying, even if that store loses internet connectivity back up to the cloud or back up to the central data center. So one of the things we've really looked at is to enhance Nomad's handling of that by really thinking about edge as a first-class concept. So now we've introduced with Nomad 1.3 the ability to have disconnected operations. So within a Nomad job specification, we now can have this new stanza, effectively the max client disconnect, which allows you to say, hey, I think this thing that runs up to 12 hours, you can tolerate the fact that the node it's running on might look to Nomad to be offline, right? But maybe it's just a retail store. It's OK that it's lost internet for a few hours at a time. Don't treat it as failed. Where Nomad typically would say the moment I've lost contact with that node, I treat it as failed and I move the application somewhere else onto another healthy node. In this case, you sort of have a 12-hour grace period. After 12 hours, we'll still detect it as failed. We'll still move it somewhere else, right? So this behavior is configurable. You can change that knob to whatever makes sense. Maybe you have an environment where you might lose connectivity for 30 days at a time. That's OK, right? You can give that flexibility to the job, and then Nomad will sort of handle that gracefully and move workload around. The next big thing that we've been focused on in that same vein of simplicity is how do we reduce all the moving pieces that you need to actually run a Nomad cluster, right? I think historically you've needed to basically have Consul with Nomad to run any sort of a microservice architecture to do the service discovery. Now, though, we've brought native service discovery with Nomad 1.3, so applications that are running on Nomad can start without Consul, right? You can do discovery of other tasks and other jobs and have that native through Nomad without needing to bring any other pieces. So going back to the notion of you can have a single node deployment just with Nomad, one static binary, nothing else required, and do basic service discovery. Obviously, it's still very tightly integrated with Consul, so as soon as you need service mesh capability, richer network automation, multi-data center type capabilities, Consul's right there for you. But from a getting started or dev test perspective, you can shrink the footprint down just to Nomad. So now maybe taking a step back from Nomad, I think one of the things we spent a lot of time thinking about is sort of the growing complexity in the developer landscape. Right? When we think about a modern sort of application stack, we kind of expect our developers to learn Kubernetes and ECS and Lambda, and Nomad and Terraform and all of these other tools in the ecosystem. And so the amount of complexity has just continued to grow, right? I often joke about it with Mitchell. When I started developing, the way I deployed was you FTP'd into production, you copied your PHP file, hit the Apache reload, and that was it. And now you have to sit there and get a PhD in YAML just to figure out how to push a new version of the app out. And so we spent a lot of time thinking about this, and you're like, how do we start to reduce that complexity, right? Rather than just keep layering and layering new tooling on top of it. And so this has really been where we spent a lot of time sort of thinking about what do developers actually want to do, right? For the most part, they just want to deploy their applications. They don't really want to have to deal with all the nuances of how it's running. And so over and over again, what we've seen from our different customers is that they've built their own sort of abstraction layers, their own deployment portals on top of their infrastructure to hide the detail from their teams, right? And make it easier for the developers to focus on what they actually care about. And so we saw this pattern over and over again, and that's what led us to actually building Waypoint. And so the idea behind Waypoint is that it's designed exactly to do that. It's a developer portal designed to enable them to do application delivery without really having to understand all the nuances of that platform. It allows them to focus on what they care about, which is build the app, deploy it, release it. I don't really want to care about what the difference is between ECS and Nomad and Kubernetes, right? Sort of abstract that for me, right? So when we talk about sort of the high-level goal, right, what we really want to do is put Waypoint effectively as the interface that straddles our different teams. So our application teams on top, they focus on their source code. They have a lightweight manifest that says, great, this is my Java app. Here's its sort of requirements. And then our operations or our platform teams, they can define how does it work underneath the hood. Yeah, we have a Docker build that pushes to Artifactory. We have Terraform to provision infrastructure. It runs on Kubernetes. We have Datadog to monitor it all. So there's a lot of moving pieces underneath this. But then from the developer viewpoint, what they get is a simple and flexible workflow, right? I can run Waypoint up, and I don't really care, is it running on Kubernetes? Is it running on Lambda? Is it ECS? It's all the same workflow for me. At the same time, Waypoint gives them an opinionated, out-of-the-box workflow on how do I do a build, how do I do a deploy, how do I do a release, but it's a flexible workflow. So if you need to customize it, to integrate a different thing, bring in a different tool, add a step to that process, you can sort of break the opinion and bring something else in, but out of the box, it has a bit of an opinion to get you going, right? So it makes it easier to get started for a development team where it's like, I just want to have a standard GitOps workflow. I don't want to have to reinvent the wheel. Obviously, for our operations teams, though, we want it to be a tool that's extensible and flexible enough to customize into whatever your environment is. We realize that we don't, very few of us want to operate a black box. So the goal is not to give you a black box. It's to allow you to bring the Lego pieces you have, plug them into Waypoint. Obviously, Waypoint has an opinion about how to integrate with them, but you can kind of customize and override that opinion. So you might say, you know what? I don't want the default way of integrating on Kubernetes. I have a custom Helm chart. This is actually how I want to deploy my app. Great. But if you don't want to customize it, we'll give you an opinion. And so in some sense, the way I think about it is what Terraform did at the infrastructure layer was to say, great, I have a standard workflow, a simple HCL-based declarative language, and then an extensible ecosystem of thousands of providers that Terraform uses that are somewhat opinionated, right? And that was at the low-level infrastructure layer. What Waypoint is now doing is bringing that same opinion up to the application layer, right? And so one of the pieces of feedback we've gotten over the last 2 years with Waypoint is that there's still this friction in getting started for the development teams because it's an open source tool. I have to run the server myself. I don't really know how to do it in a secure way. There's operational overhead with it. So ultimately, the right way to solve that is to just consume it as a cloud service. So I'm super excited today that we're introducing HCP Waypoint as well. This is going into private beta immediately. So if you're interested, yeah. Thank you so much. So for those excited, please go to the website, sign up for the private beta. We're excited to get your feedback. We want to hear more about how we can sort of improve this. But really, the goal is to make it a really simple GitOps workflow. I can sign up. It's a fully managed infrastructure. I don't really have to do much. I just hook it up to my GitHub, and I can ingress and begin deploying apps right away. So I want to give a quick example of what does this actually look like. Right? So starting from the CLI, which is what we expect most developers would want to use, they basically can run their Waypoint up command pointing at the HCP managed Waypoint infrastructure, And we can see basically it jumps right into actually doing the build of the application, pushing up our container. In this case, we're deploying the target onto Kubernetes. And then we can log into the HCP portal, and we can go in and we'll see that deployment right away. So all of the UI, all of the kind of machinery is fully managed for us, and we can see, great, we just deployed this application onto Kubernetes 20 seconds ago. And so all of the actual machinery is cloud hosted, and we can connect this back to our own platform, our own Kubernetes cluster that we're operating. So taking kind of a step back at this layer as well, lots to sort of talk about. With Nomad, obviously we're excited about the edge support. We're excited about native service discovery, really continue to push on how do we make it the simplest, most flexible tool. So you'll continue to see more from us in that vein as we go in this year. And with Waypoint, really thinking about that concept of application delivery as code. How do we have that opinionated application delivery portal, making it easy and sort of starting to hide all of these tools from our developers and making it easier for them. HCP Waypoint being a big, big part of how we plan to do that. So, you can kind of see the theme of a lot of what we've talked about here is really how do we make this experience easier? How do we think about those application teams and the developer experience for them? But we really want to think about this beyond just the products themselves. Right? I think what we know from our users is you expect our tools to work together. Oftentimes, we talk about a 1 + 1 = 3 effect with the HashiCorp portfolio. And so we focus on it from a product integration standpoint. But at the same time, I think, if we're honest, we've delivered a bit of a fragmented experience. If you're using multiple of our products, you have guides and documentation on some websites. We have community portals on other websites. And each of the product docs lives on its own website and platform. So it's made it difficult to kind of consume if you're a multi-product user. So as part of investing in that sort of a unified platform experience, we're super excited to introduce sort of developer.hashicorp, right? Affectionately, we call this dev. And it's really our attempt to start bringing all of that practitioner content into one place across all of the products, right? So whether it's documentation, learn guides, API references, tutorials, et cetera, we're bringing it all together. So it's really designed to be kind of a unified web experience for all of that, right? So we're starting with that, obviously, with our initial 2 set of products is just Vault and Waypoint to get started, and then we'll bring the rest of the portfolio over time. So I want to take a quick look at what that looks like. So now you can go to this website. It's live today. You can see all the products listed. If we jumped into Vault, you can see documentation, learn guides, tutorials. All of this is sort of now located sort of one property rather than kind of scattered across multiple different things. From that, we can see, great, we went from the docs right into tutorials. Our tutorials actually let us jump right into a running terminal. So embedded within that, we have sort of a working environment. You can play with the tools right away, sort of a sandbox type thing. And here we're switching into Waypoint. So you can see all of it is now located in one sort of accessible framework, right? So starting with these 2 products, over the next few months, you'll see us kind of move all of the products. So this is sort of an opt-in experience for now. You can still go to the Vault website, go to the Waypoint website. They have their own documentation. But over time, this will become the default home for all of our content to make it much easier to sort of navigate, search across it, discover everything, and see how the products work across and with one another. So super excited about the launch of this. That is everything we had to share with you for day 1. Hopefully, you get a chance to go join some of the sessions we have today, going into much deeper around some of the Terraform announcements, some of the Nomad and Waypoint pieces. We have a lot more in tune for you for day 2. So I hope you enjoy today and stick around. And I'm going to hand it over to our wonderful MCs. Thank you so much.